Okay, Jude, today we're going to be covering lesson 52 in your, what's it called? It's like the something in the beautiful or the magnificent or something like that or whatever. I forget what the title is. Maybe it's the best and beautiful or the pretty or something. Okay, but anyway, we're going to be talking about proportions with similar triangles. And the example had a random triangle. I picked a right triangle. This is called a 30, 60, 90 triangle. And what's great about the 30, 60, 90 triangle, and what that 30 means, the angle. So the angle, one of the angles is going to be 30. One of the other angles is going to be 60, and the biggest one is going to be 90. And this is the right triangle. You can never go wrong with the right triangle. So what's interesting about this is there's a proportion of 1, 2, 3. So whenever you have a triangle that's 30, 60, 90, the proportions of the lengths are going to be 1, 2, and 3. So we could draw this, knowing that, we could draw a similar triangle, and let's draw that over here, but a smaller version. And this is kind of rough. And we're going to call this 2, 1, 3. So we already know that this is the 30, 60, 90 triangle with these proportions. So let's say that the value here is 5. Okay, knowing what our proportions are, and we know that these are similar triangles with the same angles, 90, 60, and 30, these proportions are going to hold. So for the short one, we said it was 5. But what about the long one here? Well, to hold that proportion, you can see that it's 2 times 1. It's going to be twice as big as the short one. So this side right here has to be twice as big as this. So 2 times 5 is going to give us 10. Does that work out okay? Let's see. This has to be twice as big as this. 10 is twice as big as 5, and that fits the proportion of this similar triangle. The 2 is twice as big as 1. Okay, now we're looking at the hypotenuse, which is going to be the longest side right here. And the proportion is going to be 3 times as big as the short side. So what would be the length of this side? Let me see if you can figure it out. Do it in your head. I don't think you need a calculator. So what would you do? You would do, since this is 3 times as big as the short, this here would be 3 times as big as 5, which would give you 15. So let's see if that holds. 5, 10, 15. So this side's got to be twice as big as 5, and it is. 15 has to be 3 times as big as the short side, and this is 3 times as big as the short side. So is 15 3 times as big as 5? Yes, it is. And in reality, that's all there is to it. Now we could mix it up a little bit. Let's say we didn't know what these angles are, and we only knew one angle. They told us that the angle was 90 and the sides were 5, 10, and 15. Well, since we know that this is got, let's see what the ratios are. That's one. If this is 1, this is twice as big as the 5, so the ratio is 1 to 2 and 1 to 3, because 15 is 3 times as big as the 5. So this has a ratio 1 to 2 to 3. And what do we know about a triangle like this? Well, we see the ratios are 1 to 2 to 3. That means that the short side here has got to have, and this is the short side, it's 5, so we know that this angle has got to be 30 degrees. So we see that the 90 is 3 times as big, so that one's good. And let's say the 60 has to be twice as big as the short side, and 5 to 10, that's twice as big, so that gives us 60 degrees. So you can see, as long as you know enough information about the triangle, you'll end up with the right ratios. And remember that with this length of side, there's only one way you're going to be able to put that triangle together. If you had a side that was, well, a length that was 10, another one that was 5, and another one that was 15, which would be 1, 2, 3, let's call that 15. Try as you might, the only way that you're going to put this together is to put together into a triangle like this. So you'll always end up with a 30, 60, 90 with your angles, and since you know what your lengths are, it will always end up in this shape. And the same thing is true is with the, let's say they gave you angles. Let's call this, let me see if I got a different color, purple. Let's call this side A, B, and C. Okay, so if we're looking at the angle here at A, I guess that angle A would be equal to 60. We'll call the angle B equal to 30, and we call this angle C equal to 90 degrees. And no matter what you do, the only way to build a triangle with these angles is going to be a triangle where, let me draw it a little bit better. It's going to be a triangle like this with a ratio of 1 to 2 to 3, because that's the only way you can build this, where you're going to have an angle of 30 degrees, an angle here of 60 degrees, and an angle here of 90 degrees. And that fits our 30, 60, 90 triangle. This will work with other types of triangles. As long as you know the angles, you can figure out what the ratios are always going to be. I picked 30, 60, 90 because the ratios are a lot easier to deal with. And in reality, that's all there really is to this. You can do ratios and things like that, but it's always going to be the same. Okay, so that takes care of 52. And now we're going to move on to our next set of lessons, and we will be right back. Okay, Jude, we're back, and now we're going to go through some unit conversion. A lot of times you'll have something like, let's say you have something like, let's say 8 yards of fabric. And you want to convert that into inches. Because you're always going back and forth. You do it in recipes, you do it in a lot of different things. So you'll see this quite often. So what you do is you need to know the units of conversion. So we know 8 yard, well, we know 1 yard is equal to 3 feet. We know 1 foot is equal to 12 inches. Okay, so if they gave you 8 yards of fabric, how many inches of fabric do you have? Well, let's find out. I always like to use the bar because I always like to keep my units straight. So what do we have here and on this side here that we can use to cancel out yards in order to get to inches? And what we can also do is there a way to get from yards to inches? Well, we got yards that will get me to feet, and I got a conversion here to get me from feet to inches. So there is a path forward to get from yards to inches. And that's always important to do when you're looking at these types of problems. Is there a path to solve the problem? Okay, so I have 8 yards here. I want to get to inches, and I've got this conversion here. 1 yard is equal to 3 feet. So if I put, let's say if I put 1 yard on top, and I put 3 feet on the bottom. Okay, will that work? Let's see, I've got yards here, and I've got yards here. If I tried to use this, I'd end up with yard squared, because it's yard times yard will give me yard squared over feet. That's not what I want. So let's flip it over and see if that helps. So now I'm going to put 3 feet on top and 1 yard on the bottom. Let's see if that works better. Okay, yard on the bottom, yard on top. Much better. I can cancel out yards. Oh, good. See, my units are now in feet, so I think we're on the right track. So I'm going to draw a line, and we're going to do the same thing over here. Feet and inches. So I've got feet on top. Where do I need to put feet? So I cancel out feet, and I end up with inches. Let's see, if I got feet on top, I need to put feet on the bottom. So I'm going to put 1 foot on the bottom. And what is my conversion? Oh, that's going to be 12 inches. So I put 12 inches on top. And now I have feet cancel out. And our conversion will end up giving us 8 times 2, which is 96. Well, let's see, 3 times 8 is 24 times 12. 2 times 4 is 8. 2 times 2 is 4. 1 times 4 is 4. 1 times 2 is 2. 8, 8, 2. So this is going to be 288 inches. So the most important part about doing a problem like this is making sure you set it up so your units will cancel out. Okay? So let's take a look at something a little bit more, I guess, involved and challenging. This is probably going to be more than you'll ever need to do, but let's do it because it's fun. Math is fun. I know how much you enjoy it. And how are you doing with your square roots? Keep practicing those, because those types of practicing really helps you. It helps all of your skills. And this is what we're trying to do here. We're trying to build up your skills so in the future, with harder and harder math, it's not going to be that hard. So what we are looking at here is where is it? Where did I put it? Okay. All right. What we're going to do is we're going to take some units that you probably haven't heard of. We are going to use a beer barrel. There is actually a unit of volume called a beer barrel. And let's say somebody gave you 1/32 of a beer barrel. And would you be able to store that in your house? Is that a lot, or is that really not very much? Well, let's find out. So if I had 1/32 of a beer barrel, let's solve this into a unit that we are familiar with. So this is how you would do it. I actually have those units here. Now, if you look at it, what do I have? I have beer barrel here, and we can convert it to hogshead. And hogshead we can convert to gallons, gallons to quarts. Okay, good. We have a path forward. So let's write that down. Well, actually, I'll just keep it right here on the side so we can reference it when we need to. Okay, so now we have 1/32 of a beer barrel, and we want to know how much that really is in something that we're used to. Well, I have beer barrels here. Let's convert it to hogsheads. And where do we want to put the hogshead? We have to use beer barrel, so it'll cancel. So we'll have to put beer barrel right here. Beer barrel. And it's 1. 1 beer barrel. And I'll redraw this guy. Okay? And it's going to be 0.492. 0.492 hogsheads. Hogshead. Wouldn't it be cool if you actually got to order like sodas and stuff in hogsheads? I think that'd be kind of fun. Never had a hogshead of Coke before, but I think it'd be a lot of fun to do. Okay, so now we have hogshead. Here's hogshead here. Let's see, we want to convert it over to gallons. And as you can see, 1 hogshead is 63 gallons. So where are we going to put hogshead? Well, we got to put hogshead where we can cancel it out. Hogshead is on top. We want to put hogshead on the bottom, one hogshead. And that is 63 gallons. Wow. Okay. We're getting close. We know what gallons are, but gallons are still quite big. So let's keep converting it to something a little bit smaller. So let's take a look at our conversion. And what do we see here? Well, gallons to quarts. 1 gallon is 4 quarts. So we're going to put in, we want to cancel out gallon and end up with quarts. Gallon to quart. So we got gallons on top. So that means we got to put gallon on the bottom. And we're going to have 4 quarts on top. Okay, so far so good, but quart is still kind of big. Normally you don't drink a quart, so let's go ahead and convert quarts to pints. Okay, so here we want to cancel out quarts. And that means we want to put quart on the bottom, so we'll put 1 quart on the bottom. What are we going to put on top? Okay, it looks like quart to pint. There's 2 pints. So this will be 2 pints. Okay, let's take a look and see if we're doing this right, because we've gone quite a while without really checking anything. So here we have beer barrel on top and on the bottom. That guy cancels out, and he cancels out. We got hogshead on top and hogshead on the bottom. Okay, he cancels out. We got gallons on top and gallons on the bottom. So far we're doing everything good. And gallons cancel out. Quart on top, quart on the bottom. All right. He cancels out. So far, so good. So now we have the units in pints. So let's keep on going, because normally you drink things in ounces, right? So let's see if we can get it down to ounces so we know how much we've got. So when you drink a glass, a full glass, that's about 12 ounces. So we're used to that unit. So let's see what we have here. Well, we can go pint to gill, and then we can go from gill to ounce. So, okay, let's go from pint to gill. All right, so now we'll extend this out a little bit more. And here we have pint to gill. We have pints on top. We want to cancel pints out. So I'm going to put pint, 1 pint on the bottom. And I'm going to put 4 gills on top. I don't know where they got gills from. Hopefully not from fish, because that'd be kind of weird. And we would have pint cancel out. Now I've got 4 gills. So I think we got room for 1 more conversion. And good thing too, because we can go from gills to ounces and see what that is. And remember, this is chocolate syrup. Yum. Okay, so if we're going to go from gills to ounces, you see 1 gill is 4 ounces. Again, what do we want to do? We want to cancel out gills, and so we're going to put gill. So we've got gills on top. That means we've got to put gill on the bottom. 1 gill is 4 ounces. And you can abbreviate ounces with OZ. And we'll do that, and let's see what happens. Gill on top, gill on the bottom. We cancel that out. Okay, let's see what we end up with now. We've got the right units. Beer barrel canceled out, hogshead canceled out, gallons canceled out, quarts canceled out, pints canceled out, gills canceled out. Now we have ounces. So now all we have to do is gather together all the numbers and see what we end up with. I've got 1 over 32 and 0.492 times 63 times 4. See, I'm just going down the line, 1, and then that 0.492 is a hogshead, 63 gallons, 4 quarts, 2 pints, and I need another one here for 4 gills and 4 ounces. Okay, so let's see what we end up with. Okay, we got 32 on the bottom, and let's see what we end up with on top. What are our factors of 32? Well, let's see, 3 times 8 is 24, 4. 8 times 4 is 32. So I can write down 8 and 4, and that's the same as 32. So that just makes my factoring a little bit easier, because now let's look and see what we can do. Now that we factored 32 into 8 times 4, let's see what we can cancel. Well, we can cancel this 4 right here. 8, what are the factors of 8? Well, it's going to be 2 and 4. I've got 2 and 4 here. 2 times 4 is 8. 8, that cancels him out, and him out, and him out. Okay, so now all I have is 1 times 0.492 times 63 times 4. So let's find out what that is. And in this case, I'm just going to use a calculator to save some time. So if I've got 0.492 and 63 and 4, and I multiply that, let's see what we end up with. That is going to equal to 123.984 ounces. Okay, so if we round that up, because that's probably want to round it up to the nearest ounce, so that becomes about 124 ounces. Now, if 12 ounces is a full glass of a fluid like milk or something, you take this divided by 2, you'd end up with, let's say 12 ounces. If you divided this by 12, you get approximately 10 glasses, right? So if I had 124 ounces, and we figure it's 12 ounces for 1 glassful, we end up with, if you divide that by 12, you get about 10 full glasses. And that's pretty good for chocolate syrup. I mean, it would be tough to drink a full glass of chocolate syrup. Of course, I'm sure you boys could probably do that. But I don't think your mom is going to give you your chocolate syrup in glassfuls. I think she'll probably give it to you maybe in teaspoons. So let's say let's find out how many teaspoons we end up with. So I'm going to go ahead and take that number, 124 ounces of the chocolate syrup, and we're going to keep going on our conversion chart here, and let's see what we end up with. Well, ounces, 1 ounce is 2 tablespoons. So again, I want to cancel out ounces. So ounces is going to go on the bottom, 1 ounce. And on top, I'm going to put 2 tablespoons. And I'm going to go back to this because 2 tablespoons, and you abbreviate tablespoons with a capital T. Okay? So we're getting close. We want teaspoons. So we see 1 tablespoon is 3 teaspoons. And so we want tablespoons to cancel out. So we put 1 tablespoon on the bottom, and we put 3 teaspoons on top. Okay, so that cancels out, ounces cancels out, and let's see what we end up with. Well, we get 124 times 6, and we could probably do that. So if I go 124 times 6, 6 times 4 is 24, 2 times 6 is 12, 13, 14, 744 teaspoons. So if they gave it out in teaspoons, you'd have 744, which seems like quite a lot, but teaspoon isn't a whole lot. But let's say you had somebody that wanted to go even further, and they wanted to figure out, well, you know, if I only gave them drops, how many drops of chocolate syrup would 1/32 of a beer barrel give me? If I had 1/32 of a beer barrel, how many drops would I end up getting? Okay, let's find out. We have 744 teaspoons. Let's see what we end up with. I'm going to erase this over here, and okay, so we have okay, we're going to do the same thing. What do we do now? We got teaspoons, and we want to convert it down to drops. Let's see, we got teaspoon, we can go to dram. Never had a dram before, but that's a unit of measure. You can go from grams to minims, and then from minims to drops. Okay, so we got 1/32 of a beer barrel, which turned out to be 744 teaspoons, And now we want to get all the way down to drops. So if we have 1 teaspoon is 1.3 grams, let's see what we end up with, okay? We want to cancel out teaspoon, so I'm going to put 1 teaspoon at the bottom, and I'm going to put 1.3 gram. Okay, let's see what happens. Okay, well, we got our teaspoons to cancel out. Okay, now we have grams. Okay, now we can go from grams to minim, and then from minim to drops. Okay, next step is to go from grams to minims. Okay, we want to cancel out grams. So it's 1 gram is 60 minims. Okay, good. Look, we got grams to cancel out. Now, how many minims will give you a drop? Well, 1 minim is 1.23 drops. So we're going to put 1 minim on the bottom so we can cancel out minims. And we'll put 1.23 drops at the top. Okay, minims will cancel out. So how many drops can you get out of 1/32 of a beer barrel? Well, let's see what we end up with. We got 744 times 1.3 times 60 times 1.23. So let's find out what we get. So when we do that calculation of 744 times 1.3 times 60 times, what is this, 1.23, what do we end up with? We end up with a whole lot of drops. We get 71,379.36 drops. Can you imagine? If you want to be really economical and you didn't want to use a whole lot of the chocolate syrup, you could put 1 drop of the chocolate syrup on your ice cream and you could have 71,379 dishes of ice cream before you ran out of chocolate syrup. But I don't think that would be good because then you wouldn't be able to taste it. But isn't that cool? You can keep dividing it more and more and more. So I use this as an example because that's what you end up doing in a lot of problems. You're going from one unit to another unit to another unit. And that's all there is. You simply use your conversions to get between one and another. Alrighty, boys, I hope you like going from beer barrels to hogsheads to gallons to quarts to pints to gills to ounces, to tablespoons, to teaspoons, to drams, to minims, and finally down to the last drop. So that is what we learned in lessons 53, 54, and 55. So we will talk to you in the next part of the lesson. Okay, what we're looking at on this problem, this is lesson 55 and 56 of Unit 2 for Jude. And we're going to be converting units. So what I'm going to use in this case is volume. And we're going to do the volume of a cube. And I've drawn a cube on this side. It's always good to draw a picture so you know what we're looking for, what you're supposed to be finding, and understand what you're supposed to be finding. So what we're looking for is the length of a side. So each one of these sides, since it's a cube, is going to be exactly the same. It's going to be x. All sides are the same length. They're all going to be x all the way around. Okay. And that's what makes a cube a cube. Okay, now that's what we're looking for. We're going to try to find that value x. Another thing that we're going to be looking for is the area of a side. Well, we know the area. And what do you get when you have, actually this should be the area of a square. What do you have when you have a cube? Well, they're all built out of squares, right? There's a square here, one on the bottom, one on the side. So you got 1, 2, 3, one behind you over here, that's 4. One on that side right there, and that side right there. If I draw little dots here, you can see all of them. So this would be 1, 2, 3. Those are the 3 that we see. And then behind you, you would see 4, 5, and 6. Those would all be hidden. And I'll write the hidden ones in this pink. 4, 5, and 6. So that's the one behind us here. That's the one behind us here. And the 4 is all the way back. So there's actually 6 squares that we have, and we want to find the area of one of those. And we know the area of a square is going to be, you take a side and you square it. Now, what happens if I want to find the area of all the squares? Well, that would be 6 times the area of a square, of the square. So that's what we would end up doing. But let's just look at what we have. Let's say our volume is equal to 512 inches cubed. And we want to find, well, let's do it this way. Volume is equal to x cubed. Now we want to find, we want to find out what x is. So what do we have to do? Well, the opposite of cubing something is to take the cube root of each side, and that makes sense, right? When you take something to the exponent, the opposite is going to be the root. Like cube root, if you cube it, the opposite would be the cube root. Another way of writing this that to me makes more sense is if we wrote it like this. If I had volume is equal to x cubed, what I would do is I would take that to the 1/3 power, and I would take the v to the 1/3 power, and that's just a way of writing cube root. And what I like about this is it makes more sense to me, because as we know in exponents, we just multiply the power and the exponent. So 3 times 1/3 would be 1, so that'd be x to the first power, which would give us x. So x is equal to the volume to the 1/3 power. Okay, so now we see what we have to do. So all we gotta do is plug in our value. So x is equal to 512 inches cubed to the 1/3 power. So we do the same thing with units that we do with variables. So if we take inches cubed and we take it to the 1/3 power, see how the 3 and the 1/3 here, 3 and the 1/3 are gonna multiply out and give us 1. So that's gonna give us a unit of inches. X is a length. The length should be in inches, so this is going to give us the answer that we want. So this is going to be 512 to the 1/3 power inches. Okay, so what's 512 to the 1/3 power? I haven't taught you how to do cube roots by hand, but if you look at 512, it's going to be a power of 2. So if you do 8 times 8, that'll give you 64. I just remember this because I deal in binary all the time. And this should be the right answer. If 8 times 4 is 32, 6 times 8 is 48, for 9, 50, 51. So we see our answer is going to be 8. So that is 8 inches. So again, all we're doing when we do these things is we are looking at the units to help solve the problem. The units are in inches. This is length, and that should be in inches. And so we see that this is going to be okay. So we know the length of a side is equal to 8 inches. Okay, what about the area of a square? What is our formula for area? Area is x squared. I think I got enough room to squeeze it in here. So we know area is equal to x to the second power, right? Area is x squared, and that makes sense, right? Because if we take a look at that picture there, we got x, and x times x will give you the area. So we know that from the formula, and here's a picture to show us what it's going to look like. So that makes sense. X times x will give me the area, and that picture helps me understand what the formula is doing. So all I have to do here is A is equal, what is x? Well, we know x, the length of the side was x. X is equal to 8 inches. We have here x is equal to 8 inches. So all I have to do is pop in 8 inches squared. Okay, so 8 squared will give you 64. And we also have to do the units, inches squared. So that is going to be the area that we're looking for. So the area is 64 inches, and that makes sense because our X is in inches, and if you multiply inches times inches, you're going to end up with inches squared, which is exactly the units for area. So that takes care of that. So we know area is equal to 64 inches. So I'm going to write it down here. 64 inches. Now, let's take a look at that last question. So if I am going to look at all of the sides, and we looked at it a little bit before, you can see how many sides we have. What we want to know is, in order to do this, we have to figure out what all of the squares in a cube are. So we can count them. There are blank squares in a cube. Okay, so let's see what we had. We've got 1, 2, 3 that we can see, and then behind it we have 4, and behind here 5, and behind this, the front face, we have 6. So we know that there are 6 squares in a cube. Okay, so we can write that out. We know there are, we got 1 cube, right? There are 6 squares in a cube. That cancels out. And there are the area of a square. So we've got the we can write down 64 inches square per square, and that will let our units help us solve the problem. So cubes cancel out, squares cancel out, and we get 64 times 6. If I do that really quick, 64 times 6, 6 times 4 is 24, 2, 6 times 6 is 36, 37, 38. So that would end up being 384 inches squared. So that's if we added all those up. So we have our answer here. So in a lot of these, it's just a matter of putting together the formulas and making sure your units are all going to work out. The last part of this in 56 is when you have mixed units. Okay, this is for Jude. This is the last part of that unit section going up to lesson 60. And we're looking at converting mixed units into a common unit. So here we have beer barrel, hogshead, and gallons. And the common unit that we want to convert to is going to be gallons. And we have our conversions over here. I've abbreviated beer barrel to BB, and I've abbreviated hogshead to HH. And we have gallons, I just have as GAL for gallons. So anyway, we're going to keep bringing everything down as we go through this. So if I have one beer barrel, a half a beer barrel, that's how we would write that, half a beer barrel. And we want you to look at our conversions here. We have one beer barrel is 0.492 hogshead. So we want to cancel out beer barrel and ends up with hogshead. So I got beer barrel on the top. I need beer barrel on the bottom. So I'm going to put the beer barrel on the bottom. And you can see I put it right here, and I'm going to put the 0.492 up here. And I'm just going to add in 1/8 of a hogshead, but it's in a fraction. We do better if it's in decimal place. So let's take a look at something, and this will come second nature to you. This is going to be 0.125, and I'll show you how we get that. If I take 1, well, that's going to equal to 1, right? If I take that in half, 1/2 is 0.5. If I take half of half, I get 1/4, and that's 0.25, because I take the 0.5 and divide it by 2, I get 0.25. And if I take 1/4 and I divide it by 2 again, I get 1/8, right? Half of 1/4 is 1/8, and half of 0.25, is going to be 0.125. And you can see that, right? If I double 5, that gives me 10. Double 2 is 4, plus that 1 gives me 5. So that's where you get the 5, and 1 plus 1 is 2. So, and you can see that if I add this together, that'll give me 0.25. So you can see I divided by 2 correctly. So again, we end up with half of 4 gives me 1/8. Well, half of 1/4 gives me 1/8. Half of 0.25 gives me 0.125. So this is going to end up being 0.125 hogshead plus 14 gallons. Okay. I'm going to go ahead and erase this, and we are going to calculate this out. Let's see what we end up with. Oh, what did I forget? I forgot my units, right? That should be hogshead. So whenever you're doing this, remember to always put your units in there. One beer barrel is 0.492 hogshead. Beer barrel will cancel out, and that gives me what I want for this next step, and we're going to be doing this part next. So when I do this, I end up with this calculation. It is going to be 0.246 hogshead plus 0.125 hogshead. We're going to do that, and then we're going to add 14 gallons. Well, when I add these together, I need to convert them to gallons. So let's add these together, and I end up with 6 and 5 is 11. That's going to be 0.371 hogshead. Okay, we are not done converting yet because we have to get to gallons. So over here, I've got 1 hogshead is equal to 63 gallons. So what do I have to do? I've got to cancel out hogshead. So I got hogshead on top. I need to put hogshead on the bottom. So I'm going to put 1 hogshead on the bottom. And what's going to go on top? 63 gallons. So I put 63 gallons up here. My hogshead cancels out, and I'm going to add 14 gallons. I want to keep bringing that down so we don't lose them. So when I multiply these together, I get 23 gallons plus the 14 gallons that they gave us. And when we add these together, you can see 37. That's going to give us 37 gallons. So we converted it where we wanted to go. So we see half a beer barrel plus 1/8 of a hogshead plus 14 gallons gives us 37 gallons. And you'll see this in a lot of math problems where you have to convert between one unit and another, but it's all the same. You just have to be thorough and attention to details so you don't lose the values, and it's more tedious than it is hard. But that's all there is to it. Save me the problems that you have difficulty with, and we can go through them. In the meantime, do some square roots. I might send you a few to practice on your own. It's good practice. Gets all of your skills up to par. Anyway, love you guys.